here's the puzzle. I have 2 children, one of whom is a boy born on a Tuesday. What's the probability that my other child is a boy? So this is a great fun puzzle. And a puzzle very much like this was introduced at a maths conference a few years ago. And this caused uproar because everybody had a different answer. And I'm going to show you what I hope is the correct answer. Now, before we start, we should qualify our assumptions like all mathematicians do. I'm not trying to be clever, okay? I am assuming, because this is a probability question and for no social reason whatsoever, that children can either be boys or girls. I'm also implicitly assuming that there is a 50-50 chance of each child being a boy or a girl. In reality, that's not true, okay? So forget reality, we're focusing on the mathematics and we're trying to answer this question. But this is a hard question and I can't answer it straight away. So I'm going to replace it with a somewhat easier question by crossing out this question here. Okay, so we know the answer to this. We must know the answer. We have 2 children, one of whom is a boy. What's the probability that my other child is a boy? Everyone will tell you that the answer is 1/2. But they're wrong. Oh no, well, why are they wrong? Hey, well, let's find out. So in order to think about this, it's very handy to draw a diagram, okay? Mathematicians like diagrams, so let's put an appropriate one in. So here we have a very simple diagram, and this outlines all the possibilities that we could possibly have for our children. Okay, so we've got our first child down here, and our second child down here, and our child could either be a boy or a girl, followed by a boy or a girl. And we'll see that this question of order is kind of important in the result that we're going to get. Okay, so the question is really, what are all the possibilities of children we can have? So we could have a boy followed by a boy, okay, which corresponds to this possibility here. We could have a boy followed by a girl, which corresponds to this possibility here. We could have a girl followed by a boy, which corresponds to this one. But we may not have a girl followed by a girl. And the reason is the question tells us that one of our children is a boy. Okay, so in other words, at least one of our children is a boy. So this one here, which corresponds to girl, girl, is not allowed. Okay. So we're left with 3 possibilities: boy, 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 girl, girl, boy. Now, which of these satisfy the second part of the question? What is the probability that the other child is a boy? Okay, so in other words, what's the probability that we have 2 boys given that we have at least 1 boy? And the only event that works for this is this one here. Okay, in other words, this one here. Okay, so out of these 3 possibilities, there was one that worked for us, okay? And each of them is equally likely, so the probability to answer this simpler form of the question is just 1/3. So, this may be surprising, but this is the answer, okay, to this simpler question. Now, let's see what happens if we go back to the original question. Can we use the same technique? So here's the original question. Now, we have a bit more information in the opening statement. I have 2 children, one of whom is a boy born on a Tuesday. So people will say, well, look, this makes absolutely no difference. You've given me a little bit more information, but it's the same question as before. So the answer is going to be 1/3. Wrong, I say, wrong. It's so confusing and people argue over this. But let's see if we can help with the aid of a diagram. So here's another diagram I drew earlier. And it's similar to the other one, but it's bigger, and bigger means more fun. So let's think about the question. I have 2 children, one of whom is a boy born on a Tuesday. So what combinations of children allow this statement to be true? So it could be that my first child is the boy born on a Tuesday that I'm told in the question. So any of these along here would be possible. These would satisfy the statement at the beginning of the question. It could be that my second child, child 2, is a boy born on a Tuesday. So any of these would satisfy my condition. And note that this one in the middle, this one here, is selected twice. Okay? But that doesn't matter. These are all conditions where I have a boy who is born on a Tuesday. So now I can just say, well, look, how many of these are there? And if I count them up, then there's 14 across, okay, and there's 14 down, but I've counted this one in the middle twice. So actually there are 27 distinct ways that one of my children can be born on a Tuesday. Now, let's think about it. How many of these are such that my other child is a boy? Well, it's these ones here. Okay, so again, I'm counting this one in the middle twice. Okay, and if I count these up, there are 13 of them. Okay, and actually, this is my answer. So, if I have two children, one of whom is born on a Tuesday, the probability that the other child is a boy is 13 over 27. Now, how amazing is that? Really simple mathematics have enabled us to come up with something which is entirely counterintuitive. You can understand why people were confused by the answer, but hopefully I've shown to you by the use of some careful thinking and some diagrams that 13 over 27 is indeed the answer.